The final transformation that we haven't talked about yet is rotations. And I would consider this one to be the hardest one of the four, but it's not hard. It's just more difficult than the others. So the thing I want to show you is how you can remember the process for rotations in an easy way. I don't know if you learned this in geometry or not, but this is how I remember how rotations work. Because with rotations, everything changes. You know, the numbers don't necessarily change, but their placement does, and so does their sign. So if I have this dot right here, this is my original dot in my original position, 0 degrees of rotation. I'll call this point A. And what are the coordinates of point A? 5, 1. Now if I rotate this point about the origin, so I'm rotating about the origin right here. If I rotate this point 90 degrees, when we rotate counterclockwise. So rotate counterclockwise is positive. So if I rotate this thing 90 degrees counterclockwise, it winds up right there. What are the coordinates of that point? Okay, so let's take a look. For a 90-degree rotation, let's take a look at my original ordered pair and my resulting ordered pair. What happened? Good. So if I had A comma B instead of my actual coordinates there, it would be negative B comma A. So for 90 degrees, A comma B becomes negative B comma A. The coordinates switch places, and what was once y is now x, but the sign of it has changed. If I rotate another 90 degrees, then the net rotation in the end would be from here all the way around to here. How far did I go? 180 degrees. And now my point is here. Negative 5, negative 1. So if I stick with the A comma B, what happened? What happened to my coordinates? Negative A, negative B, that's right. So for 180 degrees, A comma B becomes negative A, negative B. And what that means is you're just changing the signs of your x and your y coordinates. If I rotate once more, then I start here and I've rotated 90, 180. If I rotate one more, I get 270, and my dot is sitting right here, and the ordered pair is negative, it's positive 1 comma negative 5. So if we're talking about in terms of A and B, A comma B turned into what here? We traded the x and the y again, B and A, except this time the A changes sign. So over here for a rotation of 270 degrees, A comma B becomes B comma negative A. If I did one more 90-degree rotation, how far would I have gone? 360 degrees. A comma B just winds up being exactly where it started, A comma B. Those are the four main rotations that we're doing. And those are the four main rotations that you did in geometry as well. And typically your rotations were centered about the origin, but they don't have to be. They can be centered anywhere. They follow this pattern. So now we're going to do this with geometry. Rotate the object 90 degrees about the origin. Well, so here's the origin right here. We have our triangle that we were working with last time. We called this A, which is 1, 0. We called this one B, which is 1, 2, 3, 4. This is a different triangle, but that's okay. 5, comma 1. And then we have point C, which is 2, comma 5. And we want to rotate this object 90 degrees about the origin. So that means that this whole thing is going to rotate over here. Well, we already know what's going to happen with 5, comma 1. It rotates around and becomes B prime, which has coordinates -1, comma 5. What's going to happen to A? It becomes 0, 1. Remember, the process is you trade these two, and then you make what was once y negative. So this becomes negative. So we trade these two, and now we have 0, comma 1. We make the 0 negative. 0 doesn't care, so it just stays 0. Here we are at A prime, which is 0, comma 1. The only one left is the C. We have 2, comma 5. We trade the coordinates, and we change the sign of the new A, so this becomes -5, comma 2. Right there, C prime, -5, comma 2. And then we can draw our figure. When you're done with that figure, you should see that this thing has been sort of spun about the center dot right here, 90 degrees. It should look exactly the same. It's just rotated a little bit. So that's all lovely and stuff, but that's not what we're here for. We're here to learn how to do this using matrices. So in the end, well, in the beginning, we start with our coordinate matrix, which originally was 1, 0, 5, 1, and 2, 5. We end up with this matrix, 0, 1, -1, 5, -5, 2. From what we learned last time with reflections, we learned that we can do something to this matrix to change things the way we want them to change to wind up with a matrix that looks like this. So what could I do? Okay, if we throw the identity matrix on there, what's that?
0, 1, 1, 0, but one of the zeros and 1 to 1 is negative.
Yeah, good. So we have, if we put the identity matrix on here, the identity matrix times this matrix just gives us our original matrix. And that's not what we want. We want all of the x values to become all of the y values. And we want all the y values to become all the x values with the opposite sign that they used to have. So we're going to switch the x and the y, which means we need to write this matrix. But we want the signs in the x, the new x, to become opposite of what they once were. So we're going to put a negative sign there. So the matrix, the transformation matrix for a rotation of 90 degrees is this matrix right here. All right, up next, we're going to rotate the object 180 degrees about the origin. It is the exact same object. So let me put these labels back up here. A1, comma 0, B5, comma 1, and C2, comma 5. This thing's going to get rotated a full 180 degrees. And based on the pattern that we came up with in the beginning of this rotation thing, what do I need to do to my A and B? What do I need to do to my X and Y? I change the sign on both, right? So if I'm A1, comma 0, I'm going to be A prime is what? -1, 0. And if B is 5, comma 1, then B prime will be -5, -1. And if C is 2, 5, then C prime will be, okay, -2, -5. And I can make that figure. And you should be able to see that this object has been spun 180 degrees around so that this guy was in the lead the whole time and now is sitting down here. So my original matrix, my coefficient matrix was, or not coefficient matrix, my coordinate matrix was 1, 0, 5, 1, and 2, 5. My resulting coordinate matrix is negative 1, 0, negative 5, negative 1, and negative 2, negative 5. So what can I do to the original coordinate matrix? Multiply by the identity matrix, and both of the ones are negative. All we're doing is changing the sign of everything. All the numbers are staying in the same location. So my matrix is going to be negative 1, 0, 0, negative 1. That gets the job done. That is your rotation matrix for 180 degrees. Rotating 270 degrees means our coordinates are going to do what? Switch, and which one's negative? The A, which became B, so the new Y coordinate changes sign. So we trade these two, and the new Y coordinate changes sign, so that means A prime will be where? 0, negative 1. So there's A prime, 0, comma, negative 1. All right?
Calculus, was that an AB or a BC test?
And B will go where? 1, negative 5, which is right there, so that's my B prime. 1, comma, negative 5. And C goes where? What was it? 5, negative 2. Right there. C prime, 5, negative 2. Draw the figure. Lots of fun. Coordinate matrix is 1, 0, 5, 1, and 2, 5. The resulting matrix, 0, negative 1. That's a nice 0, 1, negative 5, and 5, negative 2. What do I need to do to make this happen? Zeros here and here, ones here and here, but the negative 1 has to be on the bottom because we're changing the sign on the bottom row. The Y coordinates change sign. That's it. That's your rotation for rotation matrix for 270 degrees. Okay, just like before with the reflections, let's put a nice summary here. Again, the more you put here, the more beneficial it's going to be for you. For each angle of rotation, get that matrix on there that gives you that rotation, and then give yourself some sort of explanation. Why is that matrix written like that? What is it doing? You might put down that example that I was showing you where you just have like the origin here, and we have that. Whatever you put on there is only going to benefit you. These are your notes, so make it good. That's space for you.